So steam generators. So ako na lang to skip tong mga parts no nga what you call this na covered ano. So basic definition is a closed vessel in which water under pressure is transformed into steam by the application of heat. So atong initon ang tubig to generate steam, no? So an ideal boiler is or has the following. The first is a simple construction, excellent workmanship, and materials conducive to low maintenance cost. So simple in construction, we want it to be simple because if it's complicated, it will be very difficult to operate, no? Especially if it is a very big machine. No? Excellent workmanship kay posible ni mabuto, no? It is actually a boiler is actually classified as an explosive ng equipment. And then materials conducive to low maintenance cost. So dapat materials na to it's easy, no, or it has a low cost to maintain. So the second one is designed and constructed to accommodate expansion and contraction properties of materials because the boiler is subjected to heat and constant heating and cooling. No? So we want to have the boiler that accommodates this scenario. So third is the adequate steam and water space. So of course, if it doesn't have enough space no for steam and water, then it might not be able to supply enough steam no, to our equipment. Okay, so to continue, the fourth one is a furnace with efficient combustion and maximum rate of heat transfer. So it should be efficient, no? Kay sayang kayo, it will be wasting fuel, no, if it's not efficient. Then responsive to sudden demands and overloads. Of course, we do not know, no? Kay for example, change magid kita mo on ta sa kurente, mo off ta sa kurente, no, na insahay mo gamit ta sa kay equipment kusog mo ka og kurente. So uh, you multiply that by the number of people and households that are using it. So mag-usab-usab gani siya. So mana it has to be responsive. And then of course it has to be easy to clean and repair. Kay ang mga fuel, mga ash, no, mga sediments, it is difficult. It has to be removed, no, from the system. Of course, ang repair niya, no, kung maguba na, no. Then factor of safety of at least code requirements. So mo na ang gingon no nga, and it is classified as an explosive nga device. So we need a factor of safety that at least no must meet the code requirements even higher. No? So it has to produce only saturated steam where the temperature and pressure are saturated. Okay, so mo na usa niya ka kuan niya. Okay, so let's look at the schematic diagram, no. So mo ni siya ang atong system sa nga ni ang turbine system here in this area. But we have also this boiler, no, murag na separate siya, no. The feed water enters, no, the boiler, and then leaves the system to supply to the turbine. Then fuel enters here in this area to give or to exchange heat with the water, no? Okay. Then it leaves out the blowdown. Okay. So muna siya ang schematic diagram na to, no? So morning economizer this ibabaw, no? So we're at the top. So feed water heater utilizing combustion gases to heat the water. Okay. Then factors influencing selection. This is taken from Kent's Mechanical Engineer's Handbook. So the factors exerting greatest influence on the selection is number one is fuel characteristics. So what kind of fuel are we using? No, if we are using biomass, so that's different from oil, no, oil based, and it's also different from coal based. No, maingon kay tag coal dili na siya uling ordinaryo, no. That is actually from fossil fuel, no? Or fossil remains. So that's the coal that is being referred to. No? Then we have capacity and steam conditions. So we know we have to have enough capacity, no, and the steam condition should be ideal, no, for the system that it will be used for. Then we also have a space condition. So if we're gonna use it in a very tight space, no, maglisod ta, no? Okay, this is a very big equipment. Even ang entry and exit sa mga parts, no, it's a factor. Then cost, of course, if we don't have enough money, then we cannot build this boiler, no. Then of course individual preference. Ganahan og pink ang tag-iya, no. So Mona, depends on the individual preference. Of course, I'm not referring to the color alone. No, I'm just joking on that. No, but individual preference would matter. No, okay. And then money ang based on the capacity. This is taken from table 2 of the Kent's Mechanical Engineer's Handbook. So this is based on the capacity. No, so we have the types of equipment, and then what are the capacities, no, that are applicable to this, no. Then if this is the capacity, then these are the required no nga mga equipment, no, gi-check kan siya, no. Okay, and then nasa yung mga notes there is boss, you have to take note of that. Then we have also based on this is the steam generating equipment, no, selection checklist ganina. It's the fuel, no, fuel burning, okay, equipment. So steam generating na siya. So if you have this capacity, no, 1,000 to 15,000, so you can use a fire tube boiler, uh, 3 down low head boiler, 2 drum vertical unit boiler, and then controlled for circulation boiler. So this is controlled in various types. So na yung mga notes, no, kani take note of that, no. Anyway, so di na nako hutdon ta na, no, but just take note nga naa ni siyang table, no. So the kinds of boiler, fire tube, so combustion gas flows inside the tubes, mo na siya. Then water tube, combustion gas flows outside the tube. So mo na siya, no. So nas ilawom ang water, no. So timan ilang kung unsang tube ng tapad ani niya. So mo na kung water ang tapad mo, ang water is flowing inside the tube, no. So kung fire ang naguna, so fire or flue gases are inside the tubes. Okay, so mo na inyong timanaan lang na para dali ra ninyo matiman-an. Okay, so mo na kataway view sa fire tube boiler. So it was discussed very well so by the reporter, so we will not dwell too much on this. So mo sa ni water tube, so also discussed well by the group, so di kita mo dwell. So naay gitawag og horizontal return tubular boiler. So this is a very common, no. This is an old one but very simple design nga until now, no, still being manufactured. So the boiler consists of a shell, a tube sheet on each end. So mingon gay tube sheet. So kuha ni siya, no, kanang ang tabo, no. For example, nakay tube nga nana. So kani siya nga mo na siya sheet of sa metal plate nga nagtabo na ning tubes, no. So mo na siya gitawag og tube sheets. Okay? And then the boiler is mounted above a steel or masonry furnace. So mo na ning furnace diri sa ubos, no. Okay? So performance of boilers. So the capacity of boilers may be stated in. So for small boilers, square feet of heating surface. So mo specify gani siya square feet of heating surface. Small boilers na no, kay dagko gani di natamong ko specify og heating surface. So rated boiler horsepower, then percentage rating. Then for large boilers, we have a maximum steam generating capacity, no. Let's look at the heating surface, no. The heating surface is that part of the boiler where there's fire on one side and water on the other side. So moingon ta nga lingi na siya, no. There's let's say water inside, no. And then we have water inside, and then fire on the outside. Ang heating surface na to kani, no. Okay. So fire on one side and water on the other side. So muna siya may heating surface nito. Heating surface of an HRT boiler, no? So natay ato lang i-denote by HS. No? Then for this HRT, so we will just have 2/3 of the area of the shell, no? And then so let's say you have a shell, no? So the 2/3 the area of the shell, no? Area of the shell. So kani siya, no? 2/3 ani nga area. Then plus surface area of all the tubes. So na many tubes ilaw, no? Surface area of all the tubes plus 2/3 area of both tube sheets. So tube sheets, no? Kani tube sheets. And then minus the combined cross-sectional area of all the tubes. So cross-sectional area sa tubes, so muna, no? So kani, no? So anyway, naman ta example ani. So muna ni, no? Uh, kaning D is the diameter of the shell, ang dagko ni, no? Ang shell dagko ni, no? Ang D sub O is the outside diameter of the tubes, no? Wala na kuan, no? Tube ni siya. So na tube dia, no? Then D sub I is the inside diameter of the tube, and then N is the number of tubes, and L is the length of the tube. So length of the tube sa ilawom niya, ang tube sa ako lang gikuan sa shell, no? So muna ang L na to, no? Okay, now ang first is kanino 2/3 area of the shell. So 2/3 pi dl. Okay? So length of the tubes man, no? Of course, ang length sa tube is equal to the length of the shell. Okay, and then kaning area of the surface area of all the tubes, so pi di. Okay, ana man na siya, no? Ang tube, no? Atong itan-aw, no? So pi kaning area, no, times L, no? Okay, mo na. Ang surface area ra ni, no? Actually kani siyang area diri. Wala nilabot diri, no? Wala nilabot diha. Okay, and then 2/3 kani both of tube sheets, so 2/3. Then sa dako man ni siya nga kuan, di ba? So kani man ni siya nga area, no? So pi d4, no? Pi over 4d squared. Pi over 4d squared. And then duha man siya kabuok, no? Both sides, so duha, no? And then 2/3 dan siya, no? Okay, 2/3 man. And then the last is the combined cross-sectional area of all the area of the tube. So ang kani is na pi over 4d squared, do squared, outside diameter times n, the number of tubes times 2, no? Okay? So times 2 pag siya. Okay? So mo na siya ang computation sa heating surface, no? So area of the tubes, no? Let's look at this example, no? So the shell is 6 feet. Then in outside diameter is 2 1/4. N is 300 tubes, no? Then the length is 10 feet, and then the internal diameter, inside diameter is 2 inch, no? So if we compute for the heating surface, we have 2/3 pi dl times pi diln plus 2/3 pi over 4 d squared times 2 minus pi over 4 do squared and times 2. So we just substitute, no, all the values. So muna 2/3 pi, then 6 feet and d, and then length is 10 feet. Then pi di is 2 inch man, 2 inch. So we divide that by 12, no? We divide that by 12. So muna na yung di. Then L is 10 feet times number of tubes, which is N. So muna. Then 2/3 pi over 4 muna dire. Then D squared, D 6 feet squared times 2, no? Then we have pi over 4 DO outside muna ni siya, no? Pi over 4 DO is 2.25 to 1/4 muna. Divide that by 12, no? Para feet tanan. Then times 300 tubes, and then times 2, no? So we will get a heating surface area of total of 1,717.59 square feet. So imagine nun lang nimo, no? Usa ka feet, no? So kani Usa ka ruler ni siya, no? Imagine na lang usa ka ruler ni. So usa ka ruler niya square ni siya, no? Niya 1,700 square, no? Kay unani, no? Square nga one tago sa ka ruler, no? So yun na ang inyong visualization, no? So rated boiler horsepower, so na kay heating surface, we divide that by X. So what is this X? So X is 14 for vertical tube boilers, 12 for horizontal tube boilers, and 10 for water tube boilers. So remember that the heating surface in this case is in feet squared. So there's also a scenario that the heating surface is in square meters. No? Then we have to use 1.1 for fire tube boilers and 0.91 for water tube boilers. Okay? And then sa board exam, no? Kanila gamitan ninyo, no? Kay kuha naman siya, no? Metric naman ta, no? So avoid using this one na lang, no? Karaan mo gani, no? Karaan ning resource nako. So don't have to use this. Kanina lang gid, no? For official. Okay, so if we have this diagram, no? Steam feed water enters and then leaves out as steam. And then you have fuel that enters and fuel and air, no? That both enters the boiler to heat the feed water, no? And turn it into steam. So we have these terms, no? Factor of evaporation. So this is the heat added to the boiler in BTU per pound divided by 970.3. So this is actually equal to this one, no? 2257 kilojoules per kilogram. I think you're familiar with this one, no? So latent heat, no? And then FE, factor evaporation, is equal to QA, no? Ingam siyang heat added. So QA divided by 970.3 or 2257. Okay, take note of the units, no? Then it can also be this one, no? HS, ang steam, no? Then divide minus HF, which is the enthalpy of the feed water. So same na same divide og 970.3 or 2257. Okay, so let's move on fast na lang, no, kay murag mahutdan tag oras, no. So equivalent evaporation is the actual steam generated in pounds per hour multiplied by the factor of evaporation. So i-multiply lang na to, no, ang mass of steam by the FE, no, the factor of evaporation that we computed in the previous slide. So if you forgot, no, this one, so you just multiply the mass of steam by the heat added divided by 970.3, or it could be 2257 in the case of kilojoules per kilogram, no. Okay, so kuan gihapon, no, HS minus HF, no. So please remember. So we have also developed boiler horsepower. Then this is equivalent evaporation. This is the one that we had previous slide, no? Then divided by the produced steam. Okay. Then if you break it down, no, you have QA divided by this one, no? This is actually the equivalent, no, of the boiler horsepower. So one boiler horsepower is equal to 35322. So kani equal na ni kani lang siya BTU lang ni siya, no, i-multiply lang siya by 1.55, no. So you will get this one, no. Okay, so take note of that lang, no. So I'm sorry you have to move fast, no, kay 15 minutes na lang, no. So percentage rating of boiler is developed boiler horsepower divided by the rated boiler horsepower, no. Mani percentage rating. So ang rated mo na ang nasa boiler plate, no, kung nakay boiler na nameplate diha, no. Kung sa kabutan diha mo na ang rated boiler horsepower. Okay? Then rate of evaporation, the mass of steam ni siya, no. Mingon gani the rate of evaporation is this one, so kilograms per hour, so mo na siya ang meaning ano niya, M sub S, no. Then heat supplied or generated by fuel, so QS, ang iyaning kuan sa fuel niya atong istoryahan na. So Q sub S. So it's actually the mass of the fuel times the calorific value of the fuel or heating value of the fuel. Okay, and then we have the equivalent specific evaporation. So just divide the mass of steam by the mass of the fuel. We multiply that by the factor of evaporation. Then we have what we call the ASME evaporation unit, which is the rate at which heat is transformed. So we have the ASME evaporation unit equal to mass of steam times the enthalpy of the steam, then subtracted by the enthalpy of the feed water. No? So mo ni siya diri. HS minus HF. Okay, and then actual specific evaporation, we have a mass of steam divided by the mass of the fuel. So the unit will be in kilogram steam per kilogram fuel. Okay, and then we have a boiler thermal efficiency. So kani QA man na siya, di ba? Mass of steam times HS minus HF. Then divided by the mass of the fuel by the heating value of the fuel. So we want to measure how efficient the boiler is. Muna, ang output niya, energy at the output minus or divided by the energy at the input. Okay? Then the net boiler efficiency, same ra gyapon nga efficiency, minusan na nato ning iyang numerator by the energy consumed by the boiler accessories. So if you have boiler accessories and it consumes energy, so we subtract that from the QA, no? Okay, so mo na siya ang net boiler efficiency, no? So let's look at an example, no? A steam boiler on a test generates 885,000 pounds of steam in a 4-hour period. The average steam pressure is 400 psia. The average steam temperature is 700 degrees Fahrenheit. The average temperature of feed water is 280 degrees Fahrenheit. If the boiler efficiency is 82.5%, and the coal has a heating value of 13.850 BTU per pound, find the average amount of coal burned in the short tons per hour. So karaan ni siya nga problem, no, but it still holds you can still get the idea, no. Then mo ni siya atong ano natay rate, steam rate. Then we have ang conditions niya, no? Then we have boiler efficiency at 8.2, feed water at 280 degrees Fahrenheit, and then heating value of the fuel is this one. So we need to find the fuel, no? The mass of fuel used in this example. So mo na siya, we can get the enthalpy of the steam at this one, no? Because we're given the two pressures, no, or other conditions. Then we have at 280 degrees Fahrenheit, so we have HF at 249.1 BTU per pound. So I think it would be easier if we will look up the values using an English system steam tables, no. So I think sa akong kwan I'm providing a same ra nga pagbasa, no, ang steam tables, but puro lang ko ano English system ang units, no. Fahrenheit, PSIA, no? Then BTU per pound. Anyway, boiler efficiency na to M sub S times quantity HS minus HF divided by MF QH. Okay, and then we're given the values, no. So given efficiency, we're given efficiency, the mass of steam. We got the enthalpies of the steam and feed water, and then given ang heating value. So we'll be able to transpose the terms to get MF. No? In this case, the mass of fuel is 21,563 pounds per hour. So ingon man siya nga short tons. So we multiply that by 1 short ton is 2,000 pounds. So we will get a value of 10.78 short tons per hour. Okay, so muna ang the first problem. Okay, so if asking for boiler economy, so we divide the mass of steam by the mass of fuel, no? So we'll get 10.26 pounds of steam per pound of fuel.